How's it going, guys? Welcome to the Talk4 Podcast. So excited to have you here today and show you this fantastic episode. Just want to say quickly that episodes like this one and all the ones before and the ones in future are made possible by people who subscribe. Hopefully, just like you. I'm going to ask you today if you can leave a subscribe, leave a follow, leave a rating, leave a like or a comment, and just support the show in the little ways that you can like that. It makes a huge difference on my end. And quickly, just want to plug as well. I've taken 30 of the best episodes of this podcast and turned them into a fantastic book that goes into 150 secrets to greatness. Each one of those 30 episodes gets crunched down into 5 of the best key takeaways from the whole talk and turns them into a fantastic book. Highly recommend you check it out. Please support the show by grabbing a copy, either a paperback or an ebook. And I can't wait to show you guys this one today. So guys, without further ado, let's get over to the episode. How's it going, guys? Welcome to episode 167 of Talk4, the quickfire podcast where we ask 4 great questions to unique and interesting people. Behind the mic today is your host, Louis Skupien. That's me. Let me introduce our very special guest for today, Jessica, callsign Sting Peterson, is going to be answering our questions today. So, Sting, how you doing today? And welcome to the show. I mean, just looking at the background you got going there, if anyone out here is watching the video of this, I think they're going to see a pretty apparent passion crossover here. So yeah, tell me all about what's going on and how's life right now?
Hi, thank you for having me. This is awesome. So life's great right now. I have a lot going on. I'm finishing up my PhD in mechanical engineering at the University of Nevada, Reno. I just finished collecting data, doing research with Test Pilot School. I tell people I have to be probably the luckiest PhD student that has an Air Force Test Pilot School supporting them, letting me fly, collect data. So I'm really excited about that. Now I'm just trying to wrap it up and get my dissertation done so I can be Dr. Sting. That's the goal.
That's unbelievable. And yeah, I was going to say, I mean, people have it on the show. Usually, if they ever say, oh yeah, not much going on kind of a thing, that's pretty rare on here because we've got so many great people who are doing incredibly inspiring things and they just never seem to stop, right? So when you do one fantastic thing in your career, you go and do the next one, and that's exactly what you're doing. So let's figure out a little bit more about exactly what all that is then. So you've obviously kind of laid a little bit of the groundwork for it there, but just over, a minute or a couple of minutes, I'd love to just get that kind of snapshot into basically everything you have been doing, what you're doing right now, and where you are, just basically, in a nutshell, a life of Sting. So let's go from there.
Sure. So I tell people I'm a non-traditional PhD student. I have about 20 years of experience in industry. So I worked as a flight test engineer for the Air Force. I was a civil servant, so never active duty. During that time, I worked on UAVs, fighter aircraft, bomber aircraft. Really, the highlight of my career was working on the automatic ground collision avoidance system on the F-16, which I think we're going to talk about more later. It saved 13 or 14 pilots' lives now today. Really, really rewarding. I got to go through test pilot school as an engineer. Backseater is what I tell people. So I did that as a civilian, and then I got to instruct at test pilot school, which was really rewarding. From there, I became the technical director for our operations group in the Air Force. And then I decided I wanted to do a total career change. So I went off to start my PhD about 2 years ago, really with a passion for learning. And I wanted to take my real world experience and use that for teaching the next generation. So that's kind of the goal, to become a college professor and inspire the next generation. I thought that I was done with the Air Force at that point, and they called me back after I'd been gone for only a couple months. So I actually still support the Air Force now, part-time. I go back about 1 week a month. I still get to fly with them. I teach in the control room, teach the students. So I kind of do all these things. I juggle them all. It's really, really awesome. And I'm just trying to kind of keep a balance with everything, keeping passionate and keeping supporting the mission.
That's absolutely brilliant. So where did all this come from then? So obviously what I'd like to do is just unpack a bit of the backstory to begin with and just lay the groundworks. And, I've kind of spoiled it for myself slightly listening to some of your other podcast appearances. But for people listening in, everyone who comes on the show aviator-wise, it usually comes from Top Gun, or it comes from air shows, or it's a family thing. I don't think it was any of those 3 for you. So can you talk me through a little bit about the early passions there and how you got involved in this, and just a little bit about the early career getting into what you're doing and the early work that got done there, and then just kind of lay the groundworks for the career path ahead?
Yeah, so many of the people that I'm surrounded by, they've wanted to fly and fighter aircraft their entire life, right? It was like their goal. For me, it wasn't. However, I will say that there were many seeds that were planted when I was a young child that I think probably set the path. I just didn't realize it at the time. I just recently was talking to my parents and I had this very faint memory, and I couldn't remember if it was actually real or not. But it turns out when I was maybe 4 or 5 years old, my grandparents took me out to Edwards Air Force Base, which is, I live near there, and we got to see the space shuttle land. And I have this very faint memory of being out on a lake bed, it being very dark, kind of cold, and a space shuttle coming in. And I think that's kind of this first faint memory that I have of aerospace and the excitement around it. From there, I went to middle school named after amazing NASA test pilot, Joe Walker. He actually, unfortunately, died in a midair collision. So I think about that. And I think that also planted the seed for me wanting to work on collision avoidance technology, saving lives, saving pilots. But these things that happened when I was young, they were in the back of my mind, but they weren't the goal. I went off, I got a college degree. The motivation to get an engineering degree is engineers made the most money straight out of undergrad. So you could have a 4-year undergrad degree and get a good job. So that was a motivation. Then I thought I'd go to law school. I had all these different things. I wasn't totally sure what I was going to do. And right towards the end of college, I had the opportunity to do an internship at Edwards Air Force Base. It's really the home of flight tests. It's where we've had the first flight of many different aircraft. Recently, the B-21 came out there, which is very exciting. And so I had an opportunity to do an internship out there. And that's really when I got the bug. So I had these seeds planted about aerospace. But once I got out there, I saw the airplanes, I saw the passion, and really, it was about the mission that the people there were working towards. It was one team trying to get the best capability for our military and for our foreign military partners. We have a lot of foreign military partners that we do programs for. And I really liked that team environment. I worked there for about 10 years before I flew for the first time. So I wasn't, I didn't know that I was going to be flying. I didn't know that I was going to have a passion for it. And I got this opportunity to start flying. My first flight was in an F-16. It was actually a two-ship, so two aircraft. We were going out and testing air collision avoidance. So how do you prevent two airplanes from hitting each other? I tell people it's like bumper airplanes in the sky. So there's a lot that goes on with that. And oh my gosh, after I flew that mission, I will say that I was totally sick the entire time. I was air sick. It was overwhelming. But I made it through it. And I was just like, wow, this is amazing. This is what I'm meant to do. And so since then, that was a little over 10 years ago, I've had the opportunity to be flying, inspiring the next generation of flight test engineers and pilots, and kind of using that. So it's kind of been this long path. But really the thing is, yeah, I didn't know that flying and becoming a flight test engineer was a path for me. But I'm so glad that I made it there through the different winding road that I went on.
Unbelievable. Right, we've got to dig into this then, because there's something that's immediately screaming out there to me that I just have to highlight. So you say first flight was in the F-16. Is that no joke? First flight in the F-16? I mean, people always have, the Cessna or the, the little 152 experience flight, or, the Piper or the Cherokee, or, the Warrior, whatever, something. Are you saying no joke? Literally first flight, other than commercial, was in an F-16?
Okay, so it was my first flight in a jet aircraft.
Okay.
My very first flight in a small airplane, not, as a passenger in a commercial aircraft, was actually with the National Test Pilot School. So the Air Force would send their new civilians, and unfortunately, we don't do this right now, but they'd send their new civilians to National Test Pilot School, which is amazing. It's in Mojave. I did a 2-week short course. And my actual first flight, I can't remember what it was in, maybe a Piper or something like that. The very first flight, we were going out to do stalls. And I remember the pilot said, okay, we're going to go out, we're going to stall the airplane. And in my mind, only flying in commercial aircraft, I'm like, that sounds like a really bad thing. We don't want to stall an airplane. And he's like, no, it's very benign. We're going to go out and do it. And I remember being terrified as I'm in this little airplane and we're going out and we get really slow and we stall the airplane. And as soon as we stall it, very benign, the nose comes down, great characteristics. So that actually was my first flight. But then after that, I really hadn't flown much. And so then, yeah, my first flight in a jet aircraft, military aircraft, was the F-16. So not totally first flight, but, there's some caveats with it.
That's unbelievable. I mean, that is such a jump. I mean, I think if you were describing the difference between if you're describing the difference between, that versus an F-16, my God, I mean, the jump there is insane, right? I mean, that must have been brutal. I mean, what was that first experience like for you? And I mean, talking about, being shoved in at the deep end, that is a highlight really right there, right?
Yeah, so I mean, there's so many things about it that are extreme, to be totally honest. The first is the equipment that you have to wear. So to fly in a fighter aircraft, you're wearing a helmet. I think you can see one behind me right there. So you're wearing a helmet, right, which is kind of heavy, and you feel a little claustrophobic. The next is the mask. So you're wearing this mask, and that's to help with your oxygen and your breathing. But that also can be very claustrophobic. There's a lot of smells. So there's the smells of what they put on the mask for keeping it lubricated. There's the smells of the oxygen that are in the cockpit. So just that you're wearing a G suit. So a G suit, we call them our fast pants. So they're pants that you wear. They inflate to help you keep blood in your brain when you're pulling G forces. So you're wearing those. So there's just all these things. You're wearing a harness. You're strapped into an ejection seat. So just the physical aspect of it, of what you're wearing, what you're smelling, that's all very, very different, and it can make you a little claustrophobic if you haven't done it before. Then there's the physical forces on your body. So as I mentioned, this first flight, we were going out and we were testing air collision avoidance. So we aren't just flying around, we're going into these simulated collisions, and then the flight control computer is very quickly rolling you. I can't remember what the number is, but it's a very high number of degrees per second roll rate, and then pulling up to 5Gs. And so it was a very dynamic sortie. And I would say that first time, man, I did not feel good. And it's known that people are not going to feel well. And the funny thing is, so during that test campaign for the air collision avoidance system, we were trying to capture lots of video and lots of content so that we could show how the system worked. And it was for a technical reason. We wanted to capture how the collision scenarios looked and how the aircraft were maneuvering. Well, for my flight, they took one of the GoPros, they mounted it backwards, so it was looking at me the entire time. And so the debrief of that flight basically entailed us watching an hour of GoPro footage of me just feeling terrible, but dealing with it, right? So it was a lot. Now, I will say, after I flew that first time, it was several months before I flew again, maybe even 6 months. I don't remember the exact number. But then when I got the opportunity to fly a second time and to go on a full-time flying status, then I got to go to the Centrifuge, where they pull you up to 9Gs and you learn how to properly G-strain. I went to the altitude chamber, where you learn about hypoxia symptoms. You get more used to your equipment. I went through much more training to be on full-time flying status. And I will proudly say, since then, I've never gotten sick in the airplane. I feel pretty much great all the time now. So it's probably, the difference between getting comfortable and knowing the equipment, knowing what to feel. But it's very typical for people the first time they fly to be pretty overwhelmed because there's a lot going on.
Absolutely. Yeah, I'd love to talk a bit about the centrifuge as well, because 9Gs, I mean, you obviously experienced that, and from everything I've experienced so far and seen as well and heard, that seems like a pretty much a rite of passage really for flight test engineers. So I mean, what was that like the first time? I mean, what does 9Gs feel like, and how do you prepare for something like that? I mean, it's obviously super high performance and very challenging on the body. So can you lay a little bit about what that's like really?
Well, so the first thing that's kind of funny about it is the better shape you're in and the lower your blood pressure is, actually the worse that you're probably going to do in the centrifuge. So they joke that the people, you want to smoke a bunch and eat a bunch of really salty food and be in terrible, terrible shape. You want to be very well hydrated. So you want to be hydrated. But other than that, so don't do that. That's not the right way to prepare. But it is funny. Marathon runners and people that are ultra athletes don't do that well because their blood pressure is so low. So to prepare for it, really you learn how to do a proper G strain. So that's a big part of it. That's why they're having you do it, is you learn how to, clench all your muscles in your body, how to keep that G strain going and not let it go, how to know when to start it. A lot of people will get behind the power curve, we'll say. So as soon as you start to feel G's come on, you need to start the G strain. And then breathing, they teach you a breathing technique because you could be pulling G's for 30 seconds or more. So you have to breathe, but it's hard when you're at G forces to breathe. So there's a special breathing technique that we do. So those are kind of the technical aspects of it. If we have time, I want to tell you though about my experience going to the centrifuge, because it was pretty funny, I think, the story of me going there. So I show up and female civilian engineer. So I would say like all these environments that I show up at, I'm a little bit unusual looking and unusual for the space. I'm different than most of the people that are there. So I show up and there were three other aviators that were in my class. One of them, I believe he was an Australian, he had been, I think, an Australian F-18 pilot, and he had been flying for a long time, and he was going to the F-35. So he had to do a higher G profile to qualify to go into the F-35. So this was his second time at the Centrifuge. And then there was two flight doctors, flight physiologists, flight doctors that were flying, I think both of them in F-15s. So they show up, one F-35 pilot, two F-15 pilots or aviators, and then me doing the F-16. And the reason that's important is the G profile that they had to do to qualify for the F-35 and the F-15. I believe they only had to go up to 8 Gs, which is still a ton. They had to go up to 8 Gs. I had to do the 9G profile. And so everyone was very worried about me. They're like, oh, she has to do the higher G profile. Like this is going to go not well for her. So they had me go last. I was going to be the last one. So first I watched the very highly experienced pilot go through the centrifuge, and they spin him, and you can watch the videos as he's going through, and he comes out, he passed it. He comes out and he was a wreck. He was totally wrecked. He comes out, he's laying on the ground. He has his feet up in the air for some reason. And I'm like, oh, this is not good. Then the F-15 flight doc goes through, and he did okay. Like it was rough, but he did okay. And then the next flight doc goes through, and he could not pass the thing. He kept letting go, like just could not pass. And he tried over and over and over. And finally he quit. And I'm like, oh my gosh, like this is not a good sign. Everyone's looking at me. And then I went and I did the centrifuge, and I totally nailed it. I did awesome. I felt great. I was smiling, and so, and I was like, oh, I'd totally do that again. So, it's one of these things, I guess you don't really know how you're going to do until you're in it. Maybe my blood pressure was high enough that day that I did great, but I was more worried about it than I needed to be. And after I passed it, and I'm like, oh, now I know how to do this, and I won't pass out in the plane.
Fantastic. So you passed, and then a whole lot of fun right after that then. So you've done some really important work. I'd love to dig into exactly what that was. And so, you passed the centrifuge, and then, a door opened, right? So what did all that look like? I mean, we know obviously a lot about Auto-GCAS, so much going on there. And I wish I could talk more about, what I'm doing also with a bit of Auto-GCAS soon as well, but that can't be spoken about yet. But this is going to be an important conversation to that project as well. So can you just talk a little bit about exactly what that is, the importance of it? What was it like working on the system? Just any specific moments as well where you saw that technology evolving and really impactful things? I mean, Edwards is the place for something like that to be developed. How did it look when that was happening?
Yeah, so Auto-GCAS, automatic ground collision avoidance system. So I think the first part is to talk about the why we needed that system. Historically, leading up to fielding that system, we were losing about 1 to 2 F-16 pilots per year in collision with the ground, controlled flight into terrain, CFIT is what it's called. And sometimes there's a lot of reasons this happen. Sometimes they lose consciousness in the airplane. They have G-lock. So that centrifuge that we just talked about, maybe they're having a bad day, they're not hydrated, or what, they don't do their G-strain well, and they pass out in the airplane. And unfortunately, we've lost a decent number of aircrew due to that. Sometimes it's in the weather. They don't realize where the ground is. Sometimes it's at night. That happens quite a bit. At nighttime, the stars can look like a city, and the city can look like stars, or over the water. These times they can get disoriented. So we were losing a lot of pilots. And so we really needed a system to prevent that. They had some warning systems that had already been put on the airplane, some preventative measures, and really it didn't reduce the numbers at all because a passed out pilot can't react to a warning system. So that was the need for it. It had been in development for quite a while. It wasn't until the 2010 timeframe when the F-16 had the capability and the computers for us to be able to get it. And really there was the need and the desire in the military to get that system. So that's kind of the background on why we did it, how the system works. And at the time it was very novel. I would say now we have so much automation in our cars and things that we're more used to automation. But at the time it was very novel, and it was a computer system that would take control away from the pilot and maneuver the aircraft away from the ground. We advertised at 1.5 or less seconds of delay. So it was made to be very, very nuisance free. so that pilots could still fly several hundred feet off the ground, do terrain following, terrain masking, those types of things. So we developed how to test that system, and to test it, we had to make sure that it would prevent all the different types of historical mishaps that were out there. So an aircraft, a pilot passed out at very high altitude going supersonic. Well, if you're passed out, your airplane starts getting steeper and steeper, going straight towards the ground very quickly. That's actually a very challenging scenario for Auto-GCAS to prevent, and even more challenging to safely test. So we had to come up with ways to test these systems. And so I got to be part of the team designing the test, making sure that we were safe and effective. And then fortunately, I actually got to go out and be in the aircraft. It makes you have a lot of trust in your safety design and your methods when you're putting yourself in the aircraft as you're diving at the ground, making sure that the system works. So we tested that. We fielded it in 2014. Went on about 640 of our Air Force F-16 aircraft. Saved, like I said, 13 or 14 pilots' lives at this point, which is amazing. And then after we fielded that system, they took a variant of the design, now is on the F-22. It's on our F-35, which has been very rewarding. And actually, just a couple weeks ago, I met with one of my former students from Test Pilot School. He's a Navy, or actually Marine test pilot, and they're very close to fielding the system for the Marines, which is awesome, all based off of the same concepts. So it's been very rewarding system to work on, and I'm very fortunate that I got to be on that program.
It's absolutely fantastic. Could we just talk a little bit about, obviously revealing what you can reveal and stuff too, but I just think it's so fascinating talking about something that's so ingenious like that and the development of that as well. Obviously, you said, quite a few years ago now as well. So obviously, like the use of AI may not have been around then and stuff too. So, a lot of work being done by, human brains to figure these things out and invent something like this, and then, take it into, the testing room, and then eventually put it out there into, the scenarios. So in terms of like doing something like that, how does that go from start to finish, from idea to something that's then integrated into the jets? What is the kind of development process there? And then I think when you're developing something new as well, and you've got to test something new like this as well, sometimes you have to write your own playbook as well, because actually you're doing something that hasn't really been done before in terms of these tests. So were there any great examples or stories there of times where you had to sort of think outside the box and test this in a certain way where, it was just required a certain mission set to be able to see? Just any interesting stories from that development, and also just the story behind how it goes from start to finish in the end product.
Yeah. So I think the first part of it, the story behind how it went from start to finish. So in the 90s is actually when they first started developing the capability, and they had a very special aircraft, test aircraft, that was an F-16 variant that they were able to do. I think it was called AFTI was the name of it. I can't remember what that acronym stands for, but that's where they started developing it. But really for the Auto-GCAS system to work, what it required was a very good navigation solution. So in order to avoid a mountain or to fly down a canyon, you have to know the accuracy of your position on the airplane. And that was one of the big challenges. And so that's kind of why I say we didn't get it, even though the knowledge of how to make it work has been around for quite a few decades. We didn't get it until 2014, because it wasn't until that point that the F-16 had a navigation system on it with that type of accuracy. Now, I'll also say that, it was very expensive to get that on the F-16s, and it wasn't put on the aircraft for collision avoidance. It was put on for other mission capabilities. And this is how a lot of these things happen with our systems, right? We're limited with time and money and resources. And so it wasn't until other requirements got the navigation solution on the F-16 that then we could get Auto-GCAS on there. So that was one of the pieces, is you had to be able to have a really good navigation solution on your aircraft. We needed to have a computer that could store information of where all the mountains were. So this is not a sensor system. It's a computing system where you have, I'd say it's like, I don't think people even use Google Earth anymore, but what Google Earth used to be. So Google Earth, where you could see all the mountains and the terrain, and you could see where everything, a militarized version of that with very, very high accuracy on everything. So we needed to have a computer system to store that. And then really the magic of Auto-GCAS is it would do a trajectory. It's called a trajectory prediction algorithm, TPA. And so it's constantly calculating, all right, if I do a maneuver right now, if I'm diving towards the ground, I do a maneuver right now, what does that trajectory look like? So what does my maneuver look like? And will that hit the ground? And so it's constantly doing that. I think it might be at 10 hertz. I don't remember how quick the update rate is, but constantly doing this trajectory. When that touches the terrain, then it'll do the fly up. So it was kind of, bringing all these pieces together. Now say the other piece of it is now you have to have a flight control computer that actually takes control and does the maneuver. The F-16 already had that capability because they had done auto terrain following, which is crazy to me. I actually had a mentor that tested the system back in the early 90s. And auto terrain following was they'd put a special pod on the F-16 that would look out front, and then they'd turn it on, and the airplane would auto fly through the valleys several hundred feet over the ground as it's using this. So the flight control computer actually already had the capability to engage and take control. It was all the pieces getting to that we had to develop to make happen. So those are kind of the technical pieces. And interrupt me if you have any questions as I'm going through it. I thought now I'd talk about how we designed the test. How do we learn about it and design a test? So as an engineer, before we started flying, several years before we started flying, I had to understand all the different pieces. So the navigation solution, the trajectory algorithm, the flight control computer, how do they work? How does it change? Because your aircraft state is going to change what it does. What does the symbology look like to the pilot? How does it engage, disengage, all the different pieces? And we worked a lot with Lockheed Martin. It was an awesome team, the Skunk Works, pretty small Lockheed Martin team that did all of this. We were out in Fort Worth, Texas with them all the time. I'd say that while I didn't design the system, right, the Lockheed guys were designing it, guys and girls, we were an integral part of the team, giving a lot of input into how it needed to be used, how the pilots were going to interface with it. So we were very involved in that. Tons of simulation. So they have amazing hardware in the loop simulators, which are really important for flight tests because you want to make sure everything works. And so we had years of time developing and testing these systems before we flew it, just knowing how it would work. And then the big part that I alluded to earlier was, how do you safely do this? So how do you test the system that's to prevent you from hitting the ground without actually hitting the ground? When I do outreach, I make the students kind of guess, and maybe I'll make you guess. How do you think we safely tested Auto-GCAS?
Well, you'd have to, I guess, put a simulation or a situation into the thing to run, but at altitude, I'm assuming.
Yeah, that's basically it. So we called it a terrain clearance buffer. So we'd artificially raise the ground. We wanted to make it as effective or as representative as possible. So we only rose the ground as much as we needed to. We did it time-based, so we always made sure the pilots had 4 seconds, that if the system didn't activate when it was supposed to, there'd be at least 4 seconds for the control room or the backseater or the pilot to recognize it, make the call, and then do a manual recovery. And so that's kind of how we designed the system. I'd say one of the biggest challenges, so if you're diving straight at like flat ground, that's relatively simple, just raise the ground. One of the challenges were the scenarios where you're flying at a mountain and the mountain's in front of you. And so we had to really think about, how do we test the system with varying mountains and canyons and making sure it works when it was supposed to. And so we had different creative ways that we did that. We did artificial, where we just made up mountains in the terrain database, but that's not very representative. So we did have some scenarios where we did have to actually fly at the mountain. And they had this contraption where, we'd look at data in the control room, but then they also had physical engineers out in the field with a contraption, using their eyes, looking at where the airplane was, and they were kind of the safety backup, that if data fell out, they could still make a radio call, and they were one more safety feature. So all these different things, we try to think of anything that could go wrong and make sure that we're mitigating those to test the system.
Absolutely. It's a great idea, and it deserved all the backing that it got, but it's a great idea until it becomes a legendary idea, and that happens when it works truly, well and truly. You were so involved in it. You were so involved in the development of this and saw it really from birth to being integrated. Could you just maybe tell me what it was like for you and the team the first time you heard that a pilot's life had been saved, or it had worked in the field, or there had been a situation where a pilot, had used Auto-GCAS when they had gone into G-lock or something? What must that have felt like after all that work you guys put in to then have that experience of being able to say, wow, we did it?
Yeah. So I'll start with kind of a sad part of it. While we were testing the system, we were testing the system for a couple of years. There actually were multiple lives that were lost, and as I mentioned, one or two pilots a year were dying due to controlled flight in the terrain, and so that was very hard. It made us feel very urgent. We're like, we have to get this fielded. We have to get the system right. I will say we really wanted to get it right because this was the first time that we had put an automatic system on our airplanes that was taking control away from a pilot, a computer taking control away. So there, there's this balance, get it out there quickly, but we have to do it right because if we do it wrong, it'll just be even more problems, right? So that's kind of the urgency that we felt while we were testing it. And we have in our report, when we published the report, we had the name of every single pilot who had lost their life due to controlled flight in the terrain. So that's how closely, that we watch these things. Once we fielded the system, so our first save, it was amazing. And I'd have to have the numbers exactly in front of me, but I want to say it's something like we had fielded the system and 2 weeks later, some crazy number like that was the first save that we had. It was a team and they did public release some of this content. I don't think the video got public release, but I think we had a screen capture of what it looked like. But it was a squadron that was getting deployed. So they were downrange, not in the United States, downrange. It was at night, and this pilot had forces on the ground. So there were our friendly forces on the ground that were being attacked. And he was coming in doing what's called a strafe maneuver. So strafe is where you use the nose of the airplane like a gun. You have to point the nose where you want the bullets to go. And so he was coming in, and he has friendly forces, and then he has enemy forces. And he was coming in and trying to protect those friendly forces, and he just could not get his aircraft on the path that he wanted. And he's coming around over and over. And I mean, he's hearing over the radio, right, that he needs to be there and getting more and more urgent. It's getting more urgent for him to get there. And ultimately, he broke the training rules. He got too low. Auto-GCAS came on, and it activated with 0.8 seconds to spare. So if it had activated 0.8 seconds later, he wouldn't have made it. And so that was amazing, right, to have that happen. I also will say that during flight tests, strafe, so looking at this maneuver where the pilots come in at a very specific flight path angle, and sometimes they get down to 100 feet above the ground, diving in. Strafe was one of the big challenges that we had, this balance between allowing them to do that maneuver and preventing them from hitting the ground. The first iteration of the software, it did not work. So in the first iteration, as the pilots were coming in, Auto-GCAS kept activating and didn't let them get down to the numbers. And in flight test, we were very adamant that this has to be fixed. We can't just turn off the system. There's mishaps in strafe. We have to make it work. And so I was very proud that we got it fixed because it was fixed. We figured out how to make it better. And that's what was fielded. And that's what the first save was. So that was really, really amazing. I'll talk about, there's a couple more saves. I mean, there's a bunch now that have happened. There was one, it might've been our second save. There was a pilot that was flying out over the water, and he was doing this maneuver, didn't realize how close he was to the ground. The system came on and saved him. And he wrote an amazing letter to our team, thanking us. I'm gonna like tear up thinking about it, but this amazing letter to us, his wife was pregnant at the time. And so talking about how the system allowed him to survive and see his daughter being born. And that was amazing. Yeah. And then I think probably the one that was really cool was there was a pilot, I think maybe it was our fourth save, a pilot, I believe he was a Norwegian pilot, so a Norwegian exchange pilot, and he was in the airplane in training, lost consciousness, loss of consciousness. And this is one of the videos you can go and find out on YouTube. So we got it publicly released and out there so people could see it. He passes out in the airplane. His wingman, who's next to him, is yelling at him over the radio to try to wake him up. Auto-GCAS comes on, saves his life. He wakes up. And he came out, him and his wingman came out and talked to us several months later. The pilot who had passed out said that he woke up, thought that he was in his bed and that his alarm was going off. So that's how disoriented he was. And his wingman said that he was watching it and just expecting to see a smoking hole in the ground, expecting to see a fireball. And then as Auto-GCAS came on, realized that the pilot was saved. So it's amazing, and like So you can tell my voice kind of emotional to think about them. And it's, yeah, been very rewarding.
It's such big work, and I think all those people owe a lot, but I mean it's truly incredible work, and what an incredible thing that you got to do, and be able to say that you got to work on. I think there's a few things to be taken away from this, and what's really standing out to me here as well is just some of the lessons maybe learned doing that as well. The thing that springs to mind initially is on two instances here. So one actually is the first example you gave of the pilot who nearly hit the ground. He's got people yelling at him over the intercom or the radio saying, we need help, kind of a thing. And each time he's, missing it, messing it up, he's getting more and more desperate. That's what I'm seeing in my head. And as that pressure is mounting, it eventually culminates in him making a critical error that without obviously Auto-GCAS would have been fatal for him. And the same thing at Edwards too. You guys had that pressure, that constant downward pressure on you to get this right, because you're losing pilots, and every day that is delayed, you almost feel like probably that could be someone else's life lost that we could have saved if we did this quicker. So you've got this pressure on speed, but sometimes too much speed or pressure downward on performance and stuff can lead to a mistake. So lessons learned from there as well, just leadership under pressure, staying mission focused, and when it all seems to be closing around you and pressure seems to be mounting to get this right, how do you sometimes not go too fast in the development of it and make sure everything's done bit by bit and kind of manage spinning all those plates, because there's so much there, right?
Yeah. I mean, I think it's important to have a healthy balance between the two, right? Like you need to have a healthy balance. I would say in flight test, it's why we say that we do all of our planning, all of our safety planning at 1G, right? Sitting at a table or in a simulator, and you try to think through your flight test techniques, your safety methods, your control room. We try to think through everything that we can. You document it in a safety package, you put it in the test cards, right? So you have this thing that you've put together. And then when you go out and you do flight tests, you don't want to do anything that's dumb, dangerous, or different than what you've already come up with. And so that's kind of what helps us, at least at the moment when you're under the pressure of flight test. You're not trying to come up with a new plan or come up with something different. You've already thought through it, and you're going through the procedures and the methods. And I will say it's really hard to do that if you're just sitting at a table making a plan. That's why I'm such a huge advocate for simulators, rehearsals, or even I'll tell my test pilot school students, if you can go out and you can practice a flight test technique, or as you're flying, coming up and thinking about how you're going to test a new system, that's what kind of helps us prepare. And so you really don't, like I said, you don't want to be coming up with something new under pressure, under the stress. You want to do that with 1G, where you're thinking clearly and you're able to just come up with a really good plan. And so that's how we do it. I would say, you kind of alluded to this, there's always a lot of programmatic pressure. For Auto-GCAS, we felt the emotional need to get it out there for the pilots. But any program that I've worked on, I mean, you always want to do it faster. You always want to do it for less. And so we always have programmatic pressure. And so there's that balance as well, right? How do we do these things quickly? And I think it's important as an engineer. We tend to engineers, we want more data. We want to do more things, right? Like we don't tend to be the fastest, I'd say, at some of these things. So I think it can be important to have that programmatic pressure, to have this balance between, how do we do things effectively and efficiently is important.
Definitely. So let's move on to a little bit about the future then. So there's two main topics I'd love to cover here then. So the first is obviously the future of the engineers and the pilots, and then after that, let's just go into a little bit about obviously the future of the technology and the things that's being done there. So if we start obviously with a little bit of the work you've done, obviously in STEM outreach efforts, can you just share a little bit about the stuff that you're doing there? Obviously the outreach flyover, the impact it had on inspiring the next generation of engineers and pilots, and what role do you believe outreach plays in the future of aerospace? I mean, I know personally it's a massive one, but I'd love to hear your take on it too. So just the future of engineers and pilots, how's that looking, and what's the work that you're doing?
Yeah, so I mean, there's a lot of numbers, different studies out there, but most of them agree that we're not producing, at least in the United States, we're not producing enough engineers for the demand that we have for the future of those. We haven't had enough pilots. We haven't had enough aviators, so there hasn't been enough of those. And so my being a little bit non-traditional in the environment that I work in, I'm one of the few females most of the time in the room. I've been trying to figure out how do I reach the students? How do I reach the kids that maybe hadn't thought of a career in engineering, maybe their parents aren't engineers, their parents aren't pilots or whatever. How do we reach them? And so that's kind of what I'm trying to do, is cast a really wide net so that we can, anyone that, thinks it's something they want to go into, they know the opportunity is there for them. So one of the events that we did for Edwards Air Force Base, this was several years ago, we did what we called a STEM outreach flyover. There was about 50 schools in the local area that we could fly over. We had to get approval. And I can't remember what level. It went to like a super high level in the Pentagon to get approval to do this flyover. And I think we didn't get approval until a couple of weeks before it happened. So it was one of those things we were waiting until the last minute. But we ended up having a T-38. I was in the T-38, F-35, and then a NASA F-18, and then also a C-17. We flew over all of these schools, and the kids were able to see us. We flew over one of my alma maters, and the kids were out all on the field, which was amazing to see. And so that event was really great. But I think what was more important than the flyover itself was all of the outreach we did leading up to it. So we created, I think, about 20 different videos highlighting all the different pilots and engineers, talking about what got them into their career, what they did. We made outreach content that the students could look at. And so we sent that out to the teachers and sent it out to the students. I personally went to 5 different schools and spoke at the schools before we flew over. And so we were just trying to make it that the kids, it wasn't just airplanes. They could see the people, the job, and what was going on with it. And so that was one of the events. I have lots of other outreach stuff. I cater my outreach depending on who the audience is and what I'm doing it for. But really, my goal is to make it accessible and for students to see, real people, not just in the movies, right? Real people doing the job with real impact. And so that's kind of my passion.
I love it. It's really great work that you guys have done. And even things like this podcast as well, doing a show like this, I think that's part of it as well, just inspiring the next generations and showing that these career paths are possible. And, they may not always be directly how you think they are. They might come in, different shapes and sizes. And sometimes, you might have certain issues. I remember Astro saying, he had, an eyesight problem, and then, things changed for him later, and then he realized actually he could become a pilot. And, there's so many great careers out there. And I think it's worth always investigating these things and looking up to find people like yourself to see what is possible. But the other thing I want to tap into today, obviously the future of all of the stuff that we're working on here. So I think if one thing's been highlighted today, it's that the F-16 is a pretty great platform for testing things, right? So everything from Auto-GCAS to what you were talking about to now, things with like the VISTA. So could you just maybe lay a bit of the groundwork there? And so what you see evolving over the next few years with technology like AI and autonomous systems, what the main key differences are between both of those, and, how a hybrid approach maybe between the two is going to play out. And also in amongst all of that too, as we'd said, talking about future pilots, future engineers and stuff, just any tips for young kids and people coming into this, and obviously, slightly more experienced people going to test pilot school and stuff. How do you stay ahead of the curve in a really evolving field like this one?
Mm-hmm. Yeah, so first, let's talk about AI. Everyone likes talking about AI. In my mind, so there's kind of different levels of autonomy. So there's automatic, which is kind of the first. And I would say what we did on Auto-GCAS, it's automatic ground collision avoidance system. And what that means is it's the same maneuver. It's repeatable. When it's going to do it changes based on aircraft state and the terrain, but it's always going to be basically the same type of maneuver, automatic. You can trust it. The next system that I worked on that we haven't talked too much about, I've alluded to it a little bit, the automatic air collision avoidance system. We called it automatic. It was probably a little bit more autonomous in my mind because it was doing some decision making, some looking at different costs. There was 9 different types of maneuvers depending on your collision scenario and what it's going to do to prevent that collision. And so the pilot didn't know exactly what type of maneuver it's going to do. It's more autonomous in making its decision. But still, it's been programmed. It has certain rules that it's following, certain logic that it's following. And so from a test perspective, how to kind of design a test around that. Artificial intelligence, and I don't really know truly how much of our systems are artificial intelligence and how much of it we're just saying that because it's kind of the buzzword right now. I will say, when someone tells me AI, I'm like, oh, okay, let's see if this is actually AI. But artificial intelligence is where you're making decisions, where the system is making decisions off of information that it has, and it might not be something that's necessarily programmed into the computer. I see in the future where this could be really great would be for detecting and then taking action based on certain faults or certain failures or certain types of things that you have to figure out, how can I safely fly, for example, with an airplane, how can I fly an airplane if I have some type of failure on it? There's also artificial intelligence that they're using for decision making, where computers and AI can really come in, is processing a lot of information and bringing that together very quickly and making a decision more than a human can, right? AI can bring in different sensors and different things that humans don't have, right? The sensors that a human has are their eyes, which we use a lot for flying, their ears a little bit, your sense of feel, maybe your sense of smell if there's smoke or fumes or something in the cockpit. But we're really pretty limited on the sensors that we have, while a computer can have a lot more of that. So there's different pros and cons with these different systems. I would say, and this is from a career of working on automatic and autonomous systems, we talked a lot about the F-16, but actually I started my career on the RQ-4 Global Hawk. Most people don't even like to talk about it, but it was a cool airplane. It was remotely piloted, but by remotely piloted, it was flown by a mouse and keyboard. There was no stick and throttle. So really the pilot was just kind of sending recommendations, and the airplane would make a decision on how to use that recommendation. So I've spent a lot of my career testing these different types of things. And I would say what humans are amazing at, and I think they're still amazing at, is being highly adaptable, highly flexible, and being able to take knowledge and experience from one domain and then apply it to another domain to make decisions. And so I don't see pilots being removed from the aircraft anytime soon. I think, we talk about having collaborative aircraft. I think that we will still have pilots for a very long time that are in the decision making, because it's just, humans are so adaptable and so creative, and there's so much time and effort that's spent on training them to be that way, that I don't see that going away anytime soon. Now, I will say, kind of to end it from a testing perspective, so the F-16, as we talked about, has been an amazing platform to test and mature a lot of these technologies for future aircraft. Auto-GCAS that we've talked about on the F-16, ultimately the goal is to get it on the F-35, which it is there now. And so we've used the F-16 for other tests of autonomous features. You talked about VISTA, which I actually have a picture. I'm going to grab it. I didn't know you were going to bring it up, but this is a picture of VISTA. If anyone is wondering what it is, it's an amazing, amazing airplane. And we use it. Actually, it was used for Auto-GCAS development. Right now, it's been used for a bunch of AI development, and it's an in-flight simulator. We call it a sandbox because we know very well kind of the limits of what it can do. It has certain safety trips. And so we can put new flight control systems. It actually has been used to develop flight control logic for new modern aircraft. But right now, we're really focusing on artificial intelligence, autonomy, how does it make decision making, dogfights, how is it going to decide what to do? We can put it on VISTA. It's in a sandbox. And if the AI makes a decision to do some type of maneuver, the airplane, pull too many G's or do something that isn't good structurally for the airplane, the sandbox will trip off. And so it's really a great feature. It's one of a kind. There's no other ones out there. One of a kind asset that resides at Test Pilot School. I've gotten to fly in it one time. That might be it. Everyone wants to fly in it. I've gotten to fly in it one time, and it's an amazing, amazing platform for testing future capabilities.
Amazing. I mean, the work you've done and all of it is just so profound, and I commend you really for the work that you've done, beyond just, the military work and STEM, you've saved lives as well in amongst all of it, and it's truly commendable. I'd love to know what's next. You've done all this stuff and you're still just plowing on ahead with just fantastic things. So what's next for Sting? What do you want to get done? What does the future look like for you? And what do you hope that your impact's going to be? That's one thing I've been talking a lot about recently as well, among friends and stuff too. I just think that, beyond work and, all the stuff that you do yourself as well and family, just like impact and legacy is an important one too. So, what do you hope your legacy is going to be within all of this and in the future as well?
Yeah, so probably one of my most important legacies is inspiring and mentoring the next generation. I've talked about it with the STEM outreach. It really was a motivation for me to go back and get the PhD. That's why I'm finishing it right now. Hopefully, I'll be done very soon. We'll see how motivated I am over the next couple months to get my dissertation complete. With that, so I'm at the University of Nevada, Reno, which is an awesome school. They just stood up an aerospace engineering program. So this is the first year that they've had an aerospace engineering program. I was actually at a high school last week in Las Vegas, an aviation focused high school, which was amazing. They had a 1905 replica of the Wright Flyer in their school that the students work on. I'm like, how many kids get to do that in high school? But so I was there talking with them and telling them about coming up to Reno, getting to be kind of on the ground floor for a building aerospace engineering program. So that's a really exciting thing that I'm working on right now is finishing the PhD here and hopefully staying if it'll have me to keep working on the program and inspiring the next group of kids here. And then from a research perspective, so what I've focused on right now with research is I'm trying to do real-time performance modeling, and the application is loss of engine scenarios. So in an aircraft, and really it's really important for general aviation, but it applies to our military fighters as well, especially our F-16s or F-35s that are a single engine airplane. When you lose an engine, depending on how you lose that engine, if it's windmilling versus being seized versus maybe you still have a little bit of thrust, the performance capability of the aircraft can change wildly. And how that performance capability changes really defines how far you can glide that airplane, how you can turn the airplane, and if you can make it to a landing field or if you're not going to make it. And there's a lot of different companies that have worked on technology for general aviation. There's a lot of rules that pilots and military aircraft can use. And so I'm trying to augment that with doing the real-time performance modeling so that you can have a little bit more information on, based on the type of failure that you've had, right? What are you actually at this moment capable of doing? And then how can you use it? It's one of the leading causes of, in general aviation, loss of engine is one of the leading causes of mishaps. It actually is quite survivable. So if you look at the numbers, it's amazing how many pilots, even if they lose an engine, they make good decisions to land in a field or, make it somewhere. And so just really trying to increase those numbers and give the pilots more tools and more information. So that's what I'm doing with my research in conjunction with working at the University of Nevada, Reno. It's just, yeah, trying to stay busy and try to keep contributing.
It's really interesting. And I feel like I've not been involved in aviation for too long, but it definitely feels like this year there's just been a lot of accidents. I mean, everything from the Black Hawk, I can't remember what the airport was, but I know that helicopter went down in a big city as well. We had that Air India flight as well. Just a lot of general aviation accidents as well, just all across the world, really, it seems that I've seen this year. So I got to ask them, talking about the work that you're doing there as well, do you still feel that kind of urgency that you did with Auto-GCAS to get some of these things out there and everything too? And do you see a world where just aviation generally, these accidents all around the block, they are just, the numbers are going down and eventually looking towards a world where aviation is just 100% always going to be safe and we almost never have accidents anymore? Is that possible?
I mean, that's the hope, right? I will say, so at least on the US side, if you look at the FAA numbers in general aviation, the number of mishaps have drastically gone down. Controlled flight in the terrain, just like on the F-16 was a problem. It's been a problem in general aviation, but with current technology that's out there, it's really gone down. The number of mishaps with loss of engine, actually the fatalities, the actual number of mishaps hasn't really gone down, but the fatalities have gone down. And a lot of that has to do with training. And it's such a multifaceted problem, right? I focus a lot on technology, trying to get technology out there to prevent these things, but training is a big part of it as well. Decision making in the cockpit, all of these things. And so you try to bring them together. I will say, nothing is ever going to be 100% safe, right? Driving our car is not 100% safe. Going out on a bike ride, there's all these things that we do that will never be 100% safe. But it's important that the mishaps aren't happening because of a lack of knowledge or a lack of technology or a lack of training, right? Like those are the things that we can try to attack and make better. And so that will kind of continue to be my passion to get those things out there. And I will say, as humans, we just decide to take risk. We have to know the risk that we're taking. And sometimes that's a decision. I would say, again, with commercial aviation, I don't want to deter anyone. Commercial aviation is actually amazingly safe. And probably one of the reasons that we've heard about so many mishaps this year is it kind of seems like once one happens, we all start focusing, you start hearing about them more in the news as well. So that happens as well, that you have a little bit of a bias, an unconscious bias that's happening. Once one happens, you hear about them more as well.
Definitely. Well, that has been the 4 questions for today's Sting. We always have that shameless plug moment at the end. This feels like a great place to go into that there as well. So, take a minute. Feel free to promote anything that you're working on, want people to take a look at, or just something you believe in. I can imagine there's so many things that you'd like to highlight there and stuff too. But, generally just from, the STEM point of view, people looking to follow maybe a similar career path to yours, or maybe just learning more about the work that you've done, or kind of digging a bit deeper into Auto-GCAS and all this sort of stuff, or Edwards. Where's the best place to start? And is there any essential reading material you recommend we go and take a look at?
Interesting. Okay, so I think I'll use my shameless plug for talking to the kids, the students, or they could be middle-aged like me, still trying to figure out what they want to do with their life. But the number one guidance that I give people is really to thrive at whatever opportunities that you're given. For me, when I first started working for the Air Force, one of the first projects that I was given was the most boring project that you could possibly imagine. I did this for a whole year, and I had to take Fortran code, which is like a dead language now. I had to take Fortran code and I had to convert it into MATLAB code. This is like 20 years ago. And they gave it to me as, the new engineer. And I was like, all right, I'm going to do this task and I'm going to do the best that I possibly can. And that one year, I learned so much because it wasn't the changing code from one thing to another that I learned, but it was what that code did. I learned about flight control systems. I learned about different sensors on the airplanes. I learned about different corrections that we had to make. I had mentors around me that I learned from. And so I really took that opportunity that didn't seem like an opportunity at first, and I thrived, and it just kind of set me up to really, move up in my career. And that's what I've done the rest of my career is I've taken these opportunities and I try to thrive at the opportunity that I've been given, grow where you're planted is what I like to say. And so that's kind of what I tell students is, look at these things. And if you do the best job that you can, people are going to notice it. They're going to highlight you and they're going to open more doors for you. So that's kind of my shameless plug for being the best that you can, for preparing yourself for the future. The future is changing a lot right now. It's really interesting. I mean, computer science. I was just reading an article about students that went into computer science 4 years ago, expecting to have all kinds of job offers. That field has really changed really quickly. And I personally have a couple friends that graduated recently with a computer science degree and are having a tough time finding jobs. So my advice to students right now would be, I think breadth of experience is very important. I think that, why an engineering degree is so great for me. When I took mechanical engineering, I took a casting, a welding, a machining class. So I knew all the hands-on how to build things. I took all the math classes, the physics, the engineering. So bringing that all together, even though I wasn't aerospace focused, it made me very adaptable in my career. And when I was talking to the maintainers and the people working on the airplanes, as we're getting Auto-GCAS on the aircraft, I had a physical understanding of the components that came together and how that all worked. So I would tell students, in preparing, give yourself a breadth of experience. And if you want to go into engineering, getting your hands dirty a little bit, working on cars or doing those types of things, I think is really important. And then I think the last thing that I'd say is it's important to have a passion. I said, okay, do awesome at whatever you're doing and get your hands dirty. Have a passion and have a kind of a focus on the why you're working on something and why that thing matters. And I think that will really help you be inspired. I'm fortunate that I've been able to work on systems that I understood very well, the why of why I was doing what I was doing. But part of that was because I asked the questions, I learned from the pilots, I learned from my mentors. And so for young students and young people, understand the why and have a passion for what you're working on.
That's some great stuff right there. Sting, you have been an absolute pleasure to host today. Honestly, just unlimited amount of just everything great for the work that you've done, and truly, truly honored to have had you speak here today. Thank you so much for it. And I think, if you're still figuring out what to do, I think one of those things just has got to be public speaking, because you're just so good at it. Everything you say is just delivered perfectly, and I'm super inspired. And I've got some time out in Edwards soon, and I just cannot wait to see more about this incredible place that I've just heard so much great stuff about. So thank you so much for joining me today for the Talk4 podcast. Just an absolute pleasure, and I'm super humbled. Thank you, Sting.
You bet. I can't wait to see what your future holds and what you get to do.
It's going to be a whole lot of fun. Guys, thank you for listening. This was episode 167. If you'd like to listen to the past episodes, go and have a look at the channel. And if you'd like to listen for the future ones as well coming up, make sure to hit the subscribe button and spread some love by leaving a like and a comment. See you in the next episode. Cheers.